In this video, we'll talk about how we can merge data frames. Because often we might be presented not one, but multiple data frames or files that we then first have to combine before we can do some further processing. The requirement for merging data frames is that there's at least one column that both of the data frames have in common. If this is not the case, then we can of course still combine them, but we would call this then just stacking them together or concatenating them. So for the merging, the data frames need to have something in common. In our example here, this is the column C. And now if we want to join the left and right data frame, we have different ways of doing this. And we can illustrate this with these examples here and also with these two circles here. So the blue circle represents our left data frame and the red circle represents our right data frame. The first join we have here is the inner join. And the first thing that we notice is that we just combine all of the columns. So we have here ABC, here CDE, so the D and E column are new and they are also added to here and also for all the other joins. But then we notice we're ending up with less rows. And that is because the inner join will only take this inner part here, so the intersection of the elements in the column that we merge on. So if we have a look at the column C, we see here the element C1 and C2, and in here we see the elements C1 and C3. So the only common element, the intersection here, is C1, which is why we only have C1 in here and not C2 or C3. And so then the rows of the left and right data frame where this C1 is present, they get combined. So we have here the elements AB and here the elements DE, and all of them get combined in here. Next up we have the left outer join. And in this join, we're taking all of the left data set, and then we can say we're joining to the outside of that whatever can be joined from the right data set. And again, we're merging on the column C, and because the only common elements are C1, this will be the only row that is considered. But now, because we're taking the whole left data set, we also have C2 in here, coming from here. But because there's nothing in the right data set for the C2, this will be empty. The right outer join works exactly the same, but we're swapping sides. So we take the whole right dataset, and in the column C, only the C1 is in common. So we're taking these elements and adding it to here. And finally, we have the outer join. And looking at the circles here, we can say that we take the union of both of the circles. So again, the column that we merge on is C, but now the outer join considers every element in this column, so C1, C2, but also here the C3. And then all the information from both of the datasets for these respective rows is merged, and for the spots where there's no fitting value, we just leave them empty. So for example, in this spot here, there cannot be an element, because even though the right data frame has a D column, there is no row where the C2 appears, and so there's also no corresponding D value. Okay, now let's actually run the Python code. So here we have one data frame with columns A, B, C. A contains integers, B contains some floats, and C contains animal names. In the second data frame, we also have this C column and then two additional float columns. So now when we run the inner join, and we do so by calling on the first data frame the merge function, pass to that our second data frame, and specify how we want to merge, which is with the inner join. So we run that, and we see that it combined all the columns, but we only get the rows where there were common elements in the C column. And these elements are the mouse and the fish. So mouse and fish are here, and also here. Now onto the left outer join. Here you can see we're taking the whole left data frame, and from the right data frame we take the elements where the merge was possible. So again, mouse and fish. And for the other values, we have nans. Onto the right outer join, here we're doing the same thing, except that the sides are swapped. And then finally the outer join. Here we're combining all the elements from the column that we merged on. And if there's information from either of the other data frames for the other columns, then they get filled in and the rest will be nans. Last but not least, we'll have a look at some of the special cases. So what if there's overlapping column names? So our first data frame had the columns A, B, C, and now we renamed the columns of our second data frame to C, A, E. So now both of the data frames have the C and the A columns. And if we simply run the merge like we did before, then we're now only getting the rows where there are common elements in both of the columns, so A and C. So mouse is in the C column, the common element, and 1 is the common element in A. Because here we have integers and here we have floats, that can be fixed by converting the A column to a float. So if we run that, then we get the same output, but without a warning. Now, what if we want to merge as we did before, so just on the C column? In this case, we add the argument on and pass that the column that we want to merge on. So in this case, C. And if we run that, then both of the A columns will be merged into this data frame, and they also differentiate with the X and Y. But this might be a little bit confusing because we cannot be sure from which of the data frames these columns are. And we can fix that by adding suffixes. So first we have from data frame 1, because that's the one we merge on, and then as a second one, because that's the one we pass, we have from data frame 2. And now these two columns are properly differentiated.